I'm going to talk a bit about container networking at scale. Actually, I was just talking to Xanthan, who gave the previous talk, that he made my job easier because I was also going to talk a bit about Cilium. Again, great talk. Those who weren't there should check it out after things are done. So, hi, my name is Yash. I'm currently working as a senior DevOps engineer at Sprinkler. You can know more about me at my website. I'm also contributing to a few other communities as well, mostly diving more into the networking aspects. I'm always happy to talk about container networking, Kubernetes in general. So if you are around, please reach out to me and let's talk more about that. We are going to discuss about what is the problem at scale when it comes to the container networking aspects. Networking always has been, ever since like college days, networking has been a daunting subject, right? It's supposed to be that way, but we will discuss more about what are the scale problems that comes up, what are the current solutions. We'll introduce a bit of Cilium and how it is battle tested in most of the use cases, in my personal use cases as well, and a few orgs as well. And we have a few snippets of how we can use Cilium and what are the features that Cilium actually provides us that makes it such an amazing contender. And we'll discuss a few best practices and we'll take up a few questions here and there. Cool. So yeah, let's talk more about the scale problem. What are the scale problems? So first of all, as the businesses grow, the number of container exponentially increases, right? So there are no finite number of microservices that a org might deploy, right? So as you're scaling up and up, you might go all the way up to like 500 nodes with more than maybe like 100 microservices running, and maybe one deployment is running like 60 replicas. So it's never, there's never a finite amount, right? Now, while you're doing that, you should also think about what you're doing to your network topology as well, right? So you're complicating it a lot. So there is no finite, actually there's no mapped network topology. So you might be using an ingress, you might be using an API gateway, but at the container runtime level or at the container networking level, there is no control that you're actually gaining. So if things go down, you might have to go all the way from the top, like from the ingress level, then you have to come to the bottom, and you might waste a lot of time dealing with all these issues, while issue was something else. So performance management, as I told you, performance takes a hit. A lot of packet losses might happen. So let's just say there are 5 microservices. There's one data service, particularly that is used for interacting with your databases, right? Now, you observe a performance hit. You might debug a lot. Ultimately, you came to the conclusion that there were a lot of packet losses. How could you have avoided that? Or how could you have detected it at the first place? So you don't have to waste so much time debugging at the initial stage. So that's one of the problems. And security considerations. So again, in my in the previous talk itself, there was a lot of talk about what security concerns are there. So increasing number of containers, you are not certain what ports might be open, or let's just say you have a huge team and you are not certain on what are the configurations that are being done by the network team. Let's just say security team might raise a concern. You are not certain on, or there's no actual log maintained properly of what are the things that are allowed and what are the things that are not allowed. Resource allocation, obviously, your resources are increasing exponentially, and in this day and age, 2023, as it was mentioned in the keynote, FinOps also matter. Monitoring and troubleshooting, very interesting topic when it comes to the SRE space, like monitoring and troubleshooting. Like people do waste a lot of time actually troubleshooting a lot of wasteful things, while a lot of impactful things are being missed. So we discussed about the problems already, and these are some additional things. But yeah, moving forward, what are the current solutions, right? So we have we have great service meshes. We have the native networking that is available to us. We have the CNIs plugins. Istio, Linkerd, Cilium is one that we are going to explore. So particularly, we need to ask ourselves what tool would do better for us. So today, I'm going to talk more about Cilium and plus eBPF. So eBPF is already being talked about a lot. So that B is actually the logo for Cilium. It's called EB. And cool. So what is Cilium? So we already discussed eBPF. So Cilium is again an open source based on top of eBPF, which is helped to provide secure network connectivity between all your our application services. It is eBPF powered. So you're getting all that power. Actually, just I'm talking in a lot of generic words. So you're getting all that power from the Linux kernel itself, because Linux, like eBPF, is a sandbox program that runs directly onto your Linux kernel. So you're getting much more power. You're getting privileged context, and also Cilium has like the team behind Cilium has built a lot of great tools on top of it, right, for better observability. So one such tool is Hubble. So it is like a GUI. It is actually available in a API form and a UI format as well, where you are able to view the exact number of requests going on and coming into to your microservices. And also you can add network policies. You can block some block containers from accessing your containers from other containers. And also you can configure multi-cluster networking and improve your service discovery as well. So Cilium also offers better features like Cilium has a native integration with L7 envoy proxy, and also it supports L3 and L4, which is quite great, because you need to consider the fact that you actually have to focus on both L7 and L3. L7 at the application layer, you actually need to identify a lot of your HTTP and gRPC protocols or calls happening, as well as at the L3 level, you might need those data for your Prometheus and all those observability data for your all metrics and log or tracing activities. So you are getting all these things at the same time, which is quite great. Now, discussing more about the architecture, right? How does it work? Like, so most of people here might have heard of service meshes and how it runs, right? So there's an operator, which is like a controller, which controls the entire component of that Cilium. Now we have individual agents, which run on each and every node as a daemon set, which is responsible for capturing all those packets from your containers. So that's how Cilium works. I wanted to talk more about the internal workings of Cilium, but if time allows, we will. Cilium also has great tools like the Cilium CLI as well as Hubble CLI, which makes it easier to interact with it and also helps with the installation process better. And obviously, like Cilium, you can totally replace your CNI plugin with it, and it offers better CNI, and also you can partially replace kube proxy also with it. It works that way. You can try it out in your local as well as a few other managed offerings as well are in the process of migrating or offering that particular service. In self-managed, you are free to do whatever you can. Yeah, so why Cilium? As we discussed, it has advanced security features. Now, because of eBPF and because of the advanced metrics that you are getting, you are able to actually get all the better network policies for L4, L7 layers. So you are actually in control of what you can or what services can communicate with each other and what services can't. It is powered by eBPF. Visibility. So we'll see in one of the upcoming slides how visible your workloads are. Scalability. So yeah, this whole talk is about scale. So that's where we are talking about scalability. Cilium, because it is eBPF powered, can handle any number of requests or any type of requests as well. as also mentioned in the previous slide, it is being used by some of the major FANG companies as well. Netflix is one of the companies that uses it heavily, and also Cloudflare is also using it quite heavily. We also, because of Cilium, it's a CNCF incubated project, so it is integrated with all the great cloud native tools that we have, and it has multi-cluster support as well. You can now set up multi-tenancy as well as multi-cluster approach as well, so that works great. And it has a great community. I'm going to link all the great resources at the end of the slide, so you can check it out. Yep, so these are some of the companies that are using it. So definitely these are the companies that are at scale for sure. So they have, it is quite battle tested and good to go. So just to install Cilium, you can just simply check out the Helm package for it. And in the Helm package, you can simply see, you can also replace kubeproxy. You can pass all these flags as well. And just the generic flags are also available. I was talking about the Cilium CLI. Cilium CLI is a great way to actually check how your Cilium is performing at the current moment. So, so let's just say many people, how many of you have used Linkerd? Okay, so few people. So yeah, Linkerd also has that capability of actually getting you what is the current connectivity and everything, but it won't tell you if anything is going wrong at your container to container networking stage. It will just tell you, okay, I'm receiving these packets, or maybe these many number of pods are available for your Linkerd daemon set or something, but it won't give you much more into detail about the operators and as well as the sidecars. Good thing about Cilium, you don't need sidecars, because you're anyways going to run everything at the kernel level itself. So you are totally eliminating the use of sidecars, making your containers much more lighter, right? So you get something like this, Cilium status. You get all these, like if you have already deployed the envoy, the relay is up or not, the UI is up or not, everything. So if you can see, I have one Cilium pod that is not running for me. So it is alerting me that. And you can also set up quite a few alerts on top of this as well, which makes it even more powerful, right? So whatever tools you are using for alerts, be it Datadog, New Relic, so you can integrate it with Cilium on top of Prometheus as well, and it will send out really good alerts. We are also using it, and it works out great. So at least all the network level errors are completely eliminated because of this particular feature. Hubble is a really powerful tool, and you can just enable it using using these flags that are available in the Helm chart itself. Post you enable it, you see something like this. You see the namespace over there, and you see what are the timestamp, what is the destination port, and the verdict actually gives you two options: forwarded or dropped. So now you are actually getting all the data of if any packets are being dropped or how many packets are being forwarded. So you are getting a much more granular control over your microservices. Now I can also stop these two pods from being communicated to each other using Cilium network policies. Many people also use NFaaS for this purpose, but it's better to stick to the network policies as well. So Cilium network policies actually has support for L4 and L7 as well. So definitely this will help out in all these things. So I have also linked the demo. So in the last QR code, it will be updated soon. So you can go check out that link. You will see this Hubble UI, exactly, and you can see what all packets are running, what all packets are being transferred, and what all packets are being dropped. So that would be quite visible over there. So at the end, so for few best practices, in my opinion, yeah, definitely understand eBPF if you're using Cilium, or whatever tool you're using. Actually, it's better to battle test it before. Network policies are definitely even if you are not using Cilium, use network policies. It will block any unnecessary connectivity for like useless containers. And Cilium's integration with Envoy is something really great. Istio has a great integration also with Envoy. So, but Cilium is built on top of eBPF, so it's much more powerful, and it gives you that level of efficiency that usually things can't. And others like Hubble is great for observability. It sort of gives you like a Grafana kind of a view just for your network. And definitely plan for multi-cluster networking if you're actually in the process of setting that up. And obviously, like scalability is something that should not be feared, but actually taken advantage of. You can extend various operators, build a lot of things on top of all these native tools, especially Cilium. So please do check that out. This is the QR code. You can definitely check it out. This has all the links that I definitely recommend for Cilium. I will update it. It's right now not very much updated, but I will update it with the Hubble UI as well. You can check it out maybe in 30 minutes. Yeah, I think this presentation also will be forwarded to everyone. And yep, any questions?
My question is like, is there any benchmark available, like how fast Cilium is compared to other CNI at a certain scale?
Yeah, there is a benchmark available. You can definitely check out a lot of these blogs as well, and also at the Cilium official site. From a personal use case as well, I can not tell the exact numbers, but I can definitely tell that in a ML heavy workload as well, where there are a lot of intrinsic calls taking place at a scale of like 1,000 nodes, we have completely replaced this Cilium. We have completely replaced the native CNI with Cilium because it is offering us 10x more efficiency. So numbers are definitely something that I cannot reveal because it's confidential data, but I will link out a few documentations that you can definitely check it out. And yeah, it's all out on the Cilium blog page as well.
Okay, thank you.
Cilium, what are the security features that you have?
So,
for example, we have already FIM, Falco, and Twistlock for other Calico kind of integrations. Whether Cilium also has any native security inbuilt into it?
Yeah. So, with respect to networking, there are a lot of features. Definitely, we talked about the CNPs, Cilium Network Policies, which are which like a thing built on top of network policies itself. So at a network policy, you can limit it at a namespace level, which namespace can reach out to this, and also at an L4 level. But Cilium or L3 and L4 level, but at a Cilium scale, you can actually mention it at an L4, L7 layer as well. And also CNPs are, if you check it out, CNPs are quite powerful when it comes to port blocking as well. So these are some things that Cilium offers. Also, like port scannings are quite important when you are actually taking care of security aspects. So Hubble is great at that. So Hubble has that inbuilt port scannings as well. You can enable that. Cilium overall from a container runtime as well. Container CNI as well, networking interface as well, gives you, you can actually have a lot of granular control over what ports, pack coming in on what requests are going out as well. So that again is something that definitely a lot of these eBPF powered tools give you. But yeah, you are getting all of these things in one, and it actually integrates well with a lot of these other SecOps tools. So yeah, overall it gives us a lot of these security insights.
So when you say filtering, whether it will even block or filter out certain security like malware or
not the malware aspects. So that is like the exact scanning itself. It only handles things at network level. So it won't actually detect like if the container is at a malware level risk or not. It only it will give you insights on if like A container is reaching out to B container, but it's not supposed to. Why is it happening? Or if there is any unauthorized access happening. So these are some of the security things that Cilium can cover.
Kind of a system called trace, S-trace. Kind of.
Yeah.
Thank you.
Exactly.